So for some practice ones, we did some classroom problems. We're going to do one AI and II. And the first thing you do is plug in, please. What is the natural log of 1 over 1 minus 1? Do you know what the natural log of 1 is? 0 over 0. That is an indeterminate form. If you didn't write that down, write it down right now. On the test coming up, we'll have a quiz tomorrow. Probably what I'll do is tomorrow or Friday, since people are going to be gone. We might give that a go. And just have a couple of problems on LHopitals. Now, since it's 0 over 0, that entitles us to write the limit as x approaches 1 of the top function derivative. What is the derivative of x squared? 2x. Natural log of x squared is 1 over x squared. The chain rule is 2x. What's the derivative of x minus 1? 1. So this is the equivalent of limit as x approaches 1 of 2 over x, which is 2 over 1, which is 2. How many got 2? You want to see a little trick? You might like this. Instead of doing this whole mess, rewrite this limit as x approaches 1 of the natural log of x to the second over x minus 1. There's a property that you've learned that if you have the natural log of x times x, can I write that as the natural log of x plus the natural log of x? So how many of those are there? 2. There's 2 of them. So what's a quicker way to say there's 2 of those natural logs of x? Pull that 2 out in front. And so that's going to be the limit as x approaches 1 of 2 times 1 over x, all over 1, and then you can see the 2 over 1. Just a little quicker, but both ways are fine. All right, what kind of nightmare is this one going to be? I have tangent of 0 is 0. 1 minus cosine of 0 is 1. So is this an indeterminate form? Yep, so you got to write that first. Now, the limit, x approaches 0. Tangent x to the second. So what's the derivative of that? Let's do, what's the derivative of x squared? 2x to the first, which center of the Tootsie Pop stays the same, times, what's the derivative of tangent? Very good. Secant squared x. All over 1 minus the derivative of cosine is negative sine of x. Huh? Oh, I did that before. Thank you. Sine x. Now, put a 0 in for this. Put a 0, and you're going to get 2 times 0 times secant is 1 over cosine of 0 is 1, so this will be 1 over 0. And is 0 over 0 an indeterminate form? What? We got another one? Oh. There's a little trig thing that I think we should do here before we plug that in again. Let's try this. Tangent is sine x over cosine x. Secant is 1 over cosine x, and there's 2 of them, so it's squared, over sine of x. Do you agree with what I've done so far? And then do you also agree that these will cancel? So you're going to get 2 over 1 squared, which is 2. What? 2 again? Amazing. Did anybody get 2 for that one? Did anybody else get 2 for that? Uh-oh, I'm nervous. Did I do that wrong? 2 tangent secant squared, regular sine x, cancel out the sines, 2 over 1. That's right, isn't it? Looks good. Looks good. Let's look at D. The limit as x approaches infinity of e to the infinity over infinity. Is that just infinity over infinity? Yep, that's an indeterminate form. But the sad thing is when I take the derivative of the top, I get, what's the derivative of e to the x? E to the x. And what's the derivative of x? 1. So this is just going to be e to the infinity over 1, or just infinity over 1. And what is that? It's not an indeterminate form, so it is just infinity. Now let's talk about infinity a little bit. This can be written 2 ways, infinity or does not exist. There's no limit to it. So you could write either one of them. And I learned this morning. In AP, if you write does not exist, they'll let it go. But let's say the answer was negative infinity and you wrote positive infinity, you'd get it wrong. So to be safe, infinity, negative infinity, or does not exist is the safe bet for AP tests. That's kind of dumb, but there's 3 things it could be. You could have a limit that goes to negative infinity. You could have a limit that goes to positive infinity. Or you could have, something like this, where it was here, and then something like that, where as you approach the left, it's not equal to the right. So you could have that at C. Any other ones? How about on this slide? Any of these you had trouble with? H? Sure. Oh, you're going to like this one. The limit as x approaches 0 of the sine of 0 over the square root of 0. Is that 0 over 0? Yep, that's an indeterminate form. Then we take the limit, x approaches 0, take the derivative of sine, that's cosine x. Derivative of x to the 1/2. Whenever you see square roots, change them into powers. If you see 1 over x cubed, change it into a power, because it's so much easier to do that way. Take the derivative. So the derivative is 1/2 x to the negative 1/2. Okay. This is the same as the limit as x approaches 0 of the cosine of x. This is times 2, because this 1/2, the 2 comes up, and this is 1 over the square root of x. What's 1 over the square root of x? Where can I put that square root of x? On the top. Sure. So this is going to be cosine of 0 is 1. Square root of x is, square root of 0 is 0. What's 1 times 2 times 0? I get 0 for that limit. Want to see another way to do this one? It's going to blow your mind. It's going to blow your mind. What's sine x over x as x approaches 0? What is it? It's 1. Isn't this one close to it? But I'm going to multiply the top and bottom by square root of x. So now I'm going to get the limit as x approaches 0 of the square root of x times sine x. What's the root of x times the root of x? X. So what does this go to?
1.
So it's 0 times 1 is 0. Just another way. Just playing around. Just playing around a little bit. Any other ones? Don't say Kate. Yes. F. Oh, this one? Arctangent. Oh, don't worry about that one, because we haven't really talked about arctangent yet. But I'll do it, but you don't have to worry about that. We're not there yet. Arctangent of 0 is 0 over 0. This is an indeterminate form. So the derivative of this is going to be 1 over 1 plus x squared over 1. If you put a 0 in for x, you're going to get 1 over 1 plus 0, which is 1. That one will be 1, but don't worry about that. Okay, should we do k quickly? Limit x approaches 0 of a to the x minus b to the x over sine x. And this is a little premature too because we haven't really talked about this, but if this is 0, if x is 0, you're going to get a to the 0 minus b to the 0 over the sine of 0. What's a to the 0? So b to the 0 is also 1. Do you see how this is 0 over 0? So then the limit as x approaches 0, the derivative of a to the x, you're not going to like this, but it's a to the x times the natural log of a minus b to the x times the natural log of b. We're going to get to this in a couple days, cosine of x. So when I put a 0 in for this, what's the cosine of 0? 1. What's a to the 0? 1. What's b to the 0? 1. So you're going to get the natural log of a minus the natural log of b, and don't worry about that yet. Yeah?
Okay, I thought that I put down